Hey guys, Brian here. Welcome back to the shop. We've got thunderstorms in the area today, so I'm staying off the lift at the moment. Plus it's wet out, it's been raining. So decided to mess around a bit with a new tool I picked up here. This is a Cincinnati Spiropoint drill grinder. The Spiropoint drill grinder makes an unusual tip on drill bits. You can kind of see this S shape where the two lands meet, and basically what this thing does is it radially grinds the drill bit, and by doing that these cutting edges actually come out past the center line a little bit on each side, and they come back and meet in the center. And by doing that, it's supposed to reduce the cutting forces because you don't have that straight angle across that you get in a normal drill bit. So I've been trying it out. One of the other things is they're supposed to self-center. So I've done a bunch of fooling around. This thing is really sensitive. It's got a wheel dresser on it that you use for putting the radius on the wheel and facing it. You can put any point angle on from 80 to 180 degrees using this wheel dresser on the stones. So that's kind of a neat deal. You can also vary the amount of relief almost infinitely on that. It'll go from like 0 degrees relief to, I don't know, 30 degrees maybe. It goes quite a bit. You can supposed to be able to back cut drill bits to thin the webs. It's one of the things I found is that this works good with drill bits that have a fairly thin web in them. If they're real thick, like some of the Chinese drill bits and stuff, where they might probably make them real thick so that they're less prone to breaking. If they're real thick, it doesn't get a good point on it because the margin is so wide and it makes it hard to push through. So we've got it all centered up and everything to where it seems to be working right. Alright, so as I was saying here when the phone rang, I've been fooling with this, getting it adjusted in properly, and not sure how good this will show up because this camera doesn't really zoom well. It doesn't zoom at all, but maybe you can see that S shape to that tip. Yeah, the edge comes around like this, wraps back, and does the same thing on both sides. Alright, so maybe that'll show up there. There's a conventional drill bit point where it comes up, angles over, and if you look at it there from the side, you can see it's pretty much flat across the top, whereas this one here, it's got a bit more of a point to it. These are supposed to self-center also because they do come up to a point. So that's what we're going to grind. So as a test, when you're going to test something, you always want to go to the extremes, right? So this is a 3/4 inch drill bit. It's still got a good edge on it. It's been sharpened up a couple of times. I think I drilled a bunch of holes through a dual wheel freehanded before I had the mag drill with this, and that's why it's all chowdered up, and shank's pretty well destroyed on it from slipping and grabbing. Cutting through thin holes with real big diameter hand drills is not the greatest. But we're going to test the cutting forces ID out. This one you can still see the real clean land across the center there. So I'm going to chuck this up and drill. And got this piece of tractor drawbar here, which is pretty tough steel. So what I'm going to do is take this 3/4 drill bit and my hand drill, and I'm just going to put it on here and run it for, say, I don't know, 15 seconds or something like that, and put an indentation in it. And then I'm going to sharpen it with this other style point and do the same thing and see what it does. Also see if this thing wants to walk all over the place and if that's improved any. So that's going to be a test for this. And then once I do that, I'll show you how this machine works. It's a really complicated piece to make something so simple as a drill bit. Alright, so I got my hand drill here, and just going to push down on this good and hard, and so maybe count to 15 and we'll see what it does. Yeah, the first thing you can see is that it doesn't self-center. Alright, so 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, Alright, so that was 20 seconds at least. 20 count anyway. That's what we're going with. And there's our divot. See, about a 1/2 inch indentation there. That's about all we got. So I'm going to sharpen that dude with a new grind and see how it works. Alright, so there it is. You can see the S shape on the top where the geometry's been changed. So let's see how it cuts. First thing I notice is if it wants to try and walk off like the other one did. No, not really. It's like it'll stay put, so. Alright. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, 13,000, 14,000, 15,000, 16,000, 17,000, 18,000, 19,000, 20,000. Well, it's definitely a pretty big difference. So there it is. This was the conventional point. This was the reground point. Obviously, well, neither this is flat nor am I drilling perpendicular, so both holes are not round because of that. It's not got anything to do with the drill bit. Just the operator and the conditions. Like I said, this is a curved surface. It's not flat. It's been worn, but you can see that the difference in that point down in there. Well, we got the punch here. Let's try it. Well, I can see why that drill bit probably won't start. That's pretty hard there. Yeah, it's real hard. Okay, let's try a different piece of metal. Okay, now for this next test, I've made 3 dots each. And I've got a excellent, brand new, conventional ground 1/2-inch drill bit. And I'm going to try that to center up on those marks and see how close I can get. And then I've got one that I've ground with this Spiropoint, and we'll try the same thing and see how close I get with it. So, law of averages. Take my Randy Richards scribe here. And that's not going to mark on that mill scale good, so we'll just go with the points. It's going to be accurate enough for what we're doing here. I got the Spiropoint one in here first, so this will be the Spiropoint. Not awful, but definitely a little different. So let's try something else here. Just as a test. Put a marker. One here. And instead of bumping the trigger like I was doing to try and get it to start, I'm just going to go down on the mark. I'm just going to gun it and go and see where it ends up. We'll give it a 5-second burst and see what happens. Just to the right of the marks where I wound up by the time it caught. See if we can do better. Yep, definitely better. It's right on the mark now. We've got 2 pretty equivalent pilots there, so we put this on here. This is the Spiropoint again, and let's go for 20 on this and see how it cuts. Alright. brand new half. Well, I obviously didn't get as far. Oh, the mics are not very good on these. I don't know if you could hear that or not, but this bit has like a hammering action to it. It's got a as that chisel bounces up and down off that, and you can see it too in this point. This is the spiral, and look how smooth that hole is. And then this is the brand new chisel point drill, and you can see the marks in it and how out around it is too compared to this one. So that's pretty interesting. But like I said, I don't know if you can hear that. I bet I know how. I'll just sit you guys on here, because this GoPro will really pick up vibration, so you're on this. And alright, probably sound like a jackhammer. Pretty significant difference. Big difference in the tips it pulls out too. Again, considerable difference in the finish. So, do some mill testing another time. We'll probably get to the end of this video on drill bits. So at this point, you're probably asking yourself, Brian, why, if I figured out how to make this better drill bit, did this not catch on and become kind of an industry standard? And I'm about to show you the reasons why. After fooling with this thing, I can pretty well figure it out. So let's take a look at why this idea didn't catch on. We'll say one of the reasons is contained here in this naval tag on this thing, where the cost of this thing was $3,320 in 1959. $3,320, 1959. So basically, today this would be, I guess, a $33,000 drill grinder. And this one only has capacity of an 1/8 inch to 3/4 of an inch. Although it actually has expanded capacity. This one's got an attachment on it that lets it go down to a 60 thousandths drill bit. But that was an extra cost, and it's not in this. Anyway, so the next thing that will contribute to this is the operation is not straightforward too much. It is fairly simple once you get the machine set up. You can go in and you got an end feed to feed your drill bit in and do your grinding. So that's pretty simple. But where this becomes complicated is in the dressing of this wheel. That's the critical part. Is the outside diameter of this wheel is extremely critical, because that's what forms the point on the end of the bit, because the radius, the outside of that wheel, is what makes that outside. So it's critical to be the right diameter, because if it's off, if it's too big, then your one side will blow over the other side and you'll grind this tip flat. And if it's too small, then you end up with a big wide ledge on the top of this, and you would need a hydraulic press to push this thing through the material. It won't cut because you got that big flat on the end of it, and it's just like trying to push a pin through a piece of steel. So that's not good. So that's the most critical part of this wheel. Actually, this thing is set up in the dresser to dress a slightly different radius for the different diameter drill bits, but for the most part, I don't think that's super critical. You just end up with a little bit more of a point on the bigger drills than what would be industry recommended, but they cut good like that. It's kind of like having a pilot drill built in, so I wouldn't fool with that. Once you get this, main thing is getting the outside diameter of this dress to the right dimension. If you get that, you'll get a good bit. If you don't get that, you won't get a good bit. The other thing too is that this vise has to be exactly centered, because that thing rotating around, and if it's not exactly centered, your point will be off, and then your drill bit's cut crooked and everything else. Also, it'll dress the front side of this cutting edge on one side or the other, because the wheel will come into it when it's cutting its radius if it's not just exactly right. So you don't want that either. And that's kind of where it plays in about the real thick web drills not being good, because if they're real thick, wide in here, that wheel wants to catch as it comes around, and part of what it sharpens, it grinds back off, and you get a dull face. And the drill will cut good on this outside, but it won't cut good on the inside. And that's where this point design has its advantages on the inside. I mean, if you can eliminate having to do pilot holes, that's a big production savings. Also, the fact that it cuts smoother, I think that's a big plus. And the fact that you can vary the face angles on this. They actually show doing this as a 180 tip for doing sheet metal, and it kind of works like a tree panning tool. You get your little point to start, and then it cuts through the outside edge first, and you don't get a burr and it doesn't grab. So at some point in time, maybe I'll do a drill bit like that just to try it out, but I need to find some more grinder wheels for this. This is a 2x2 grinder wheel, and they're kind of hard to come up with, so I'll be looking for those. And let's see, you say, well, it don't look like a whole lot. I mean, you got a cool little cabinet on here for storing your goodies in. This is the deal that you put in here for setting the diamond dresser, and that's the critical part to getting this radius, the outside diameter of this stone correct, for it to cut your drill bits right. So gotta have this to set this to get that, so that you get a good bit. And it's got a dust ejection system, a little blower down in the bottom of it, and a filter to collect all the grinder dust, so that's pretty nice. Then let's take this cover off here and take a look. That's right, you take the dress off and you find out why this thing cost $3,300 in 1959. This is no piece of Chi-Com machinery here by any means. This is a fine example of what ended up killing off the American machine tool manufacturers. This is all just to grind drill bits. So you can see all the rollers in there. We've got each of these shafts is ground. This is scraped, for I don't know what reason. Maybe they did it to train people, because nothing rubs against this. It's only for clearance. So I don't know what the deal was with that, other than maybe they used it as an alignment deal, because all this is part of the cams that does the reciprocation to get the radial movement. So got all the springs and rollers, and everything is made top notch. You know, you got the shafts, pull screws in them. Everything's double locked with set screws and balls underneath of them. So here's the big cam in here. The gears that drive this. And this is part of the mechanism that locates it for when it goes into the grind system. The base, all springs and everything. I mean, this thing was built to do a job for sure, and that's what it was doing. And it does a pretty nice job once you get it set up. So, no semi-finished tooling here. Let's start it up and you can see it in motion. So you can see this cam is what controls the radial movement. It also controls the side to side. The side to side decreases and increases with the wheel movement. The smaller your drill bit, the less movement. So you can see the big bits rock around. And this controls how much air. So if I crank this up, you can see that thing really strokes like that. That's cutting a lot of degrees of relief right there. When you crank it down like that and barely got any relief. Okay, so I'm sure y'all would like to see a drill bit ground on this, so we've got this chowdered up 1/2 inch here. Pretty sad shape. So get it in here. So you got the tool over, push this up, turn it till it stops, lock it down, back it out, this out of the way, fire it up, put your grind diameter, 1/2 an inch, and then feed in. Spark out. there's the completed tip. With that double chisel. So you want to know what the point looks like. This is a conventional point drill. As you rotate it, you can see that big radius. Look how big that radius is. It's it's like a 80 thou max at 10x. Now we'll compare it to this spiral point we just ground. As I rotate it through, you can see the big difference there. So we've got a max radius of probably 30 on that point. Right there, you got a nearly perfect chisel. That's what lets that thing self-center, is that little point right there. First, again, here was the conventional bit. It's right there, the self-center, but as soon as you turn it, boom. Look at that big honking radius on the end of that. Sorry, I'm not real good at holding still, especially at 10 times movement. I gotta hold these drill bits because they'll fall off the table. So there's a bit on drill bit geometry for you. Maybe that'll give you a better understanding of how drill bits cut and what makes them work or not work. Alright folks, so that's that. Today's tangent on drill bits and making holes and drill bit geometry. Just playing around with this new tool, and I got a whole cabinet of drill bits that I can sharpen at some point in time, but that's not today's issue. I'm going to try and get out there and do some work on the barn now that the thunderstorms are cleared out of here, more or less. So if anybody wants to do some more scientific testing of drill bits, I'd be glad to sharpen a couple up for you and send them out. These drill bits definitely have some performance advantages. They cut better. And it's a big difference that I notice is how smooth they are with no chatter. They probably don't walk up. They're supposed to not walk off as much, and they're supposed to hold hole size better. So it'd be interesting to see head-to-head testing and that with something else. But for today, that's it. So thanks for watching and thanks for subscribing. And if anybody has any questions, I'll be glad to answer them. Took me a better part of a day to get this thing figured out and ironed out and getting it working properly to make the ideal drill bit points that it's supposed to do. After I got everything adjusted, it's pretty easy and straightforward to use. But getting it adjusted is definitely a challenge. I can see a lot of shops, if they had these as maintenance guys, would probably have a fit trying to get one to cut right, because it's a finicky little beast. So, hope you enjoyed, and I'll catch y'all later.